Hello everyone, welcome to my channel. This is Naresh Chenno. In today's session, we'll see the problems on networks, which contains how we can apply KVL, KCL, and voltage divider rule and current divider rule. All we'll see in detailed. Today's first problem is finding the I1, I2, and I3 in this network. If you see, first we have to find the I1. Where it is I1? I1 is here. The direction of I1 is up. So if you put node here, so I1 is entering, 2 amps is leaving, 12 amps is leaving. So by using KCL, it means at a particular node, the sum of the entering currents equal to sum of the leaving currents. So for that, I will use KCL here at node A. Node A, if you see, I1 is entering equal to 2 amps plus 12 amps are leaving. So I1 equal to 14 amps. So I1 we found. Simply you applied the KCL here and we saw entering and leaving currents. Now we'll find I2. Where is I2? I2 is here. So it is leaving from this node. So for this node, entering current is 12 amps, leaving current is 14 amps, and one more leaving current is I2. So now we can write I2 plus 14 equal to 12 amps, because 12 amps is entering, and these two currents are leaving. So I2 equal to 12 minus 14. We got minus 2 amps. So I2 is minus 2 amps. Now we'll find the I3. Again we'll see I3. So if you see here, I3 is leaving from this branch and entering at this branch. So I3 is entering at this branch. So we know now I2 and 8 amps and I1 is incoming. I3 is incoming. So for this particular node, I will see at node C, what and all entering? I2 plus I3 is entering. Here 8 amps is leaving. So we have I3 equal to 8 minus I2. What we got? I2 is minus 2. So 8 minus of minus 2. So 8 plus 2, it is 10 amps. So I3 is 10 amps. This is what? Finding the I1, I2, I3. For the next problem, same. By using KCL, we'll find I1 to I4. See here. See, now we have to find the I1. I1, if at this node, we'll assume A. At A, I1 is entering, I2 is entering, and 2 amps is leaving. This 2 amps current is leaving. So we'll write KCL at node A. KCL at node A. First we'll write the equations. After that we'll find the I1, I2, I3, I4. So at node A, KCL is what? Entering current I1 plus I2 equal to leaving current 2 amps. This is our first equation. And if you see I2, I1, I2, we require, if you see here at this node B, is 7 amps is leaving, 3 amps is leaving, and I2 also leaving. So we'll write at node B, KCL is sum of the leaving equal to sum of the entering. So we don't have any entering current. So sum of 7 amps, 3 amps plus I2 equal to 0. So by this I2 we got minus 10 amps. So now I2 will put in this equation. So I1 equal to 2 minus I2. So 2 minus of minus 10, we got 12 amps. So we found I1 and I2. Now we'll see I3. So at this junction again, we'll take a C. Again KCL at node C. So what and all entering? 7 amps entering, I4 entering, I3 leaving. So entering current 7 plus I4 equal to I3. But we don't know I3 and I4. Now we will apply the KCL at this node. This we will assume node A. Node D. KCL at node D. So again you see this is leaving, and 2 amps entering. This 2 amps is coming like this. So again KCL at node A, sum of leaving currents I4 plus 4 amps equal to sum of entering currents 2 amps. So from this I4 equal to 2 minus 4, we got minus 2 amps. So now this will put here, therefore I3 equal to I3 minus 7, sorry, this I3 equal to I4, I3 equal to what we got I4 no? So simply this will use, now here I4 equal to minus 2, 7 minus 2 equal to I3, we have I3 equal to 5 amps. So all we got. So first one is we got what, this is I1 we got, I2 we got, I3 we got, and finally this is I4. So like this we can use the KCL at every particular node to find the at that particular node the currents. So next this problem we'll see, we'll find the current I. Where is current I? So this is the current I, this current I. If you see this network, we have so many voltage sources and current source, but we no need of anything. Simply we'll write the KCL at one particular node and we'll solve for that. So here if I apply KCL, this 1 amp is like this, and if you see this 4 amps so current also entering at this, so 4 amps. Now this I will take node A, KCL at node A is sum of entering currents. So 4 amps is entering, 1 amp and I is leaving. So sum of entering is equal to sum of leaving. This is 1 amps. 1 amps. No need to write. So I equal to 4 minus 1 equal to 3 amps. So this is our answer. So simply to find I, you apply the KCL here, and for this one 1. So we'll got I equal to 3 amps. This is by KCL simply found the I. Now we'll find the I in the network by using Ohm's law. See what does Ohm's law says is V equal to I. This is the equation for Ohm's law. So now if you see this 30 volt source connected with one particular resistor 5 k ohm. So by using this, what is I? Simply V by R. So this is only one voltage source with one resistor. So directly we can find current by using Ohm's law, that is 30 volt divided by 5k, we got 6 milliamps. This is the answer for this question. This is 6 milliamps. So in this network current is 6 milliamps. When we have multiple voltage source, we can't use directly V or particular like V. So in that case we will use KVL. So how we'll use KVL is, see in this problem, next we'll see this problem. Here also we have to find the I. I is not simply I equal to V by R. I can't take 10 or 20 or 4. It is sum of V divided by R. This sum also again conditions are there. Directly we can't add all these sources. We'll write now KVL and we'll see how we can write this total V. Now see, in my previous lecture I explained about the KVL. So this is current I in this in the direction is coming. So this is I. So now for passive component, the entering I terminal I will take as a positive and this is negative. Now I will write the KVL in this direction. So this is negative, this is positive. I am going negative to positive. I will write 20 volts minus 20 volts. Here I am coming positive to negative. I will write minus 10. Again it is minus 2, positive to negative. I will write minus 3 times I. Again it is negative to positive. I will write plus 4 volts, but this value is minus 4. That's why I will write that particular value equal to 0. How much we got? 20 minus 10, 10 minus 4, 6 equal to 3i. From this I equal to 2 amps. This is the way we can find the I in the network. Or one more way we can find the I. How it is see. No need to write KVL. So directly we'll find the I. See, now if you see all these sources, this 20, 10 and this minus 4, see, positive to positive, it is connected. So this will be subtracted, and this negative to this negative connected. Again, this also will be subtracted. So how we can write is, for current I, directly I can write 20 minus 10 plus, I will take this is x to make you clear. I will take this source is x divided by what, 3 ohm resistor. So now 20 minus 10, in place of x you put minus 4 divided by 3. So much, 20 minus 10, 10 minus 4, 6 by 3, which is 2 amps. So same answer we got here also, 2 amps. Here only thing is, while you are writing the directly sum of all this voltage source, you should take care of sign. Means if it is like this, see, this I will take 10, 20 and 30. This is 5 ohm, this is I. So here we can write I directly. See, this 30 positive and this positive connected, so you can do subtraction, 30 minus 20, and for this 30 volts it is positive, so means this is positive and this is negative, so I will put addition. So like that we can continue. So 30, 40 minus 20, 20 by 5, we have 4 amps for this particular network. So directly we can write in the such way that this positive connected subtract, again this positive, this negative connected, so addition. Like this we can continue, or we can use KVL and we can write the current. So this is all about finding the I in this particular network. We'll see next. Yeah, now also finding the current and voltage at VAB. So VA is here, VB is here. First we have to find the I in the network. So to find I, we'll use the KVL. So again, current is going like this, so I will take 30. So current is entering like this, we'll take positive here. So this is I. So my positive to negative, 3I. Again negative to positive, plus 10 volts, minus, again it is positive, it is negative. So minus 5I, again positive to negative, minus 8 equal to 0. Now simply 3I plus 5I minus 8I, will take that side, it is 8I. 30 plus 40 minus 8, it is 32 equal to 8I. I equal to 4 amps. This is what current in the network. Or we can solve by using this method also. Earlier what I explained, see now. Or we can find I by using sum of V by sum of R. So for this one, see, now I will take reference as 30 volts, and this is connected in reverse. So I will take positive, 30 plus 10. If you see here, with respect to 30, same sign, so I will subtract, divide by sum of resistance, 3 and 5, it is 8. Now if you see 30, 32 by 8, it is again 4 amps. This is method 1 and this is method 2. So both way we can get the I. In both way we can do. One, we can apply KVL, or by using this method only we can apply when only single loop is there. That case we can find directly by summing of V by summing of R. So this is all about finding the current. Now we have to find the voltage at this particular this. So again we have to apply the KVL. Means in this way fashion we apply the KVL to find this. Now I will apply the KVL. So again current is this direction. So 30 minus, again positive negative, minus 3I plus 10 minus VAB equal to, in this loop I applied the KVL. So here it is, we have already found the current, that is how much, 4 amps. So 30 minus 3 into 4, 12, 10 equal to VAB. From here we have VAB equal to how much, 30 plus 10, 40 minus 12, it is 28 volts. So 30 plus 40 minus 12, we have got 28 volts this voltage. So this is all about applying the KVL and finding the current in two ways. So I hope you clear this point. So we will move for other question. So now see, finding the V0 in the circuit and power dissipated by control source. Which is control source? This is controlled source. We have to find the power dissipated in this controlled source and we have to find the V0. So to find V0, see the current 10 amps is up coming here, and this is 2 V0 also coming up to here. This is 2 V0. At this node I will apply the KCL. This is, I will assume, current I. So at node A, by using KCL, sum of the entering currents equal to sum of the leaving currents. These two are entering and this is leaving. So I can write 10 plus 2 V0 equal to what, I. I will assume this is first equation. See, now to find this V0 we should know the current I. For that one what we'll do, this V0 we can write in terms of these 4 and I. By using Ohm's law, what V equal to IR, means the current entering at this terminal, if it is positive negative V, we can write this is R. We use V equal to IR. So same thing I will use here. V0 is here and current entering this way, positive negative. I will write, if I write 4 times I, but this is minus, because if you take resistor, current entering like this is R, I0, this V. In this case V equal to IR, but here as per question they mentioned V0 equal to this way, that's why I have put minus here. So now we got V0 equal to minus 4 times of I. Now from by using equation 1 we have V0, and by using equation 1 we have the relation between V and I. So we will replace this V0 with here 10 plus 2 times of minus 4I equal to I. Now 10 equal to I plus 8I. So I equal to 10 by 9 amps. This is about finding the I. So now we require the V0. So V0 is this, by equation 2 by 2 V0 equal to minus 4 times of I. I is 10 by 9. So minus 40 by 9 volts. Simply finding the Vx. Vx in this, it is here. So now here it is about dependent sources. when dependent sources comes, the one controlled variable it will be there. So you always concentrate on controllable variable. So this controllable variable is Vx. So Vx is, I will assume current I is going in this fashion. So now simply Vx equal to 5 times I. This will assume 1. Now we will find the current in this loop. That is only I. If you see now 15, we will apply KVL. 15 minus 1 times of I minus 2x minus 5y minus 2I equal to 0. What we got here? 15, 2, 5, 1 minus 8I equal to 2Vx. This is 2. By using 1 and 2, we'll substitute. In place of Vx, we'll put 5y. 15 minus 8I equal to 2 times of 5I. We got 10I. 15 minus 8I. So 15 equal to 89. We got I equal to 5 by 6 amps. So now we got the I. To find Vx, we will use again equation 1, that is Vx equal to 5 times I. Now 5 equal to 5 by 6. Now Vx equal to 25 by 6 volts. This is, we got the Vx. See, simply when dependent sources are given, you concentrate on controllable variable and you make two equations, equation 1 and equation 2 in this fashion, and try to solve the two unknowns from two equations. Finally, we end up with the Vx equal to 25 by 6. So I hope you all understand the concept clearly. If any suggestions or doubts, please comment in the video and please subscribe my channel. Thank you for watching.